compute simplify the following, stating any domain restrictions. Obviously many of you could just plug this in a calculator and get a decimal form. The idea here is to build some skills that you could use later for when you don't just have numbers. So some people just look at this and they remember top times top, bottom times bottom, much like if you're multiplying 2/4, which is just a half of a half, let's say, is the same as a quarter, which in this case gives me 2/8. But I could have also just simplified those 2's to give me 1/4. I could have simplified the 2 and the 4 to give me 1/4. So there's lots of simplifications we can do before we just compute. Likewise, in this problem, you could have just said, well, it's 45/75, and then trying to simplify that further. 5 goes in, so it's 9/15, and then 3 goes into that, 3/5. Or you could have just tried to factor first. So 5 is just 5, 3 is 3, times 3 times 3 over 5 times 5. So 3 goes with 3, 5 goes with 5, and I'm left with 3/5. Just like that, in one step. The next one, so now factoring is going to come in handy for simplifying. Notice there are no domain restrictions here because there is no variable, there's no input, so there's nothing to restrict. On this one, however, there are probably restrictions, so again, let's lay this flat just so you can see. 5 times x plus 5 times 5 times x. Notice they both have a 5 and an x, so we will take those and factor those out. So we're left with 9y over 5x times x plus 5 times 10 times x times y over an 18 I'll factor. In fact, I'm going to leave 9 on top factored as well. That's 3 times y. And you'll see y in a second. I'm doing this. 10 I will leave factored as 2 times 5. And 18 is just 2 times 3 times 3 times y cubed, which is y times y times y. So from a simplifying point of view, many people ask me, oh, can I, which directions can I simplify? And I say, well, what makes sense? So let's try something and see if we can make some sense of it. 3/5 and 15/9. And we want to multiply those. So let's just compute it first. So this is 45/45, which is 1. Okay, so we should be able to get 1 out of this in our simplification approach. So let's try first simplify within a fraction. So what that means is up, down. Can I simplify this way? Well, 3/5 doesn't simplify, but I can divide top and bottom by 3 to get 5/3. And so when I multiply across, I get 15/15, which is still 1. So it would be a mathematically accurate thing to do, to simplify up and down. So simplify within a fraction, check. Cross simplify, many people call it, which is this direction, simplifying, almost like cross multiplying, but you're not cross multiplying because you can only cross multiply over an equal sign. So let's see if that works. So 3 goes into 3 once, into 9 3 times, 5 goes into 5 once, into 15 3 times, 1 over 1 times 3 over 3 is definitely 1. So that works. And now let's see if we can find out if it works to simplify across. Which is like this. So 5 and 9, nothing common, but 3 and 15. Well, that's 1 and 5. So then I get 5 over 45. Is that the same as 1? Definitely not. So simplify across is no good. Okay, so often you can just use numbers as, to your advantage, to help you decide what rules make sense and which don't make sense. And really simplification is a division problem, and one of the reasons this works is if I have a times b over, or if I have a times b, or a over b times b over a. Well, when I multiply, I'm just multiplying the top and the top and the bottom and the bottom. And so this is just AB over AB. And AB, A simplified, B simplified. So AB is the same as BA. The order doesn't matter in multiplication. That's the commutative property, and so that's why this works, is that I could basically extend the fraction bar and just treat this as one big fraction, since the order of the multiplication doesn't really matter. So let's do that, and now see if we can simplify. So I need to look for whole factors. 5 is a factor, x is a factor, x plus 5 is a factor, 2, 3, 3, y, y, y. We can't just look for pieces. I can't just look for a piece like, oh, well, there's a 5 in there. No, the factor is x plus 5, and so if I'm going to divide it out, I need to divide the whole factor. So, where do we have whole factors that we can divide? Well, if we look up and down, we have a y and a y here. We have a 2 and a 2. Across, we have a 5 and a 5, and an x and an x, and a y and a y, and 2 3s and 2 3s. And that's it. So I believe we're left with, and we can always look again once we have it laid out. X plus 5 times y. And that's it. But I, of course, simplified without looking for my domain restrictions. I should not have done that. I should have started before I started crossing out, look for domain restrictions. So x cannot be, in this one right here, 0. And this third factor there, negative 5. And y cannot be 0 because of all these y's in the denominator. So these are my domain restrictions, and that's my solution. So the idea here is, simplify, factor and simplify, and look for restrictions, and then you can really, boil down some fairly complicated problems into things that are much simpler to picture.